All right, everyone, what we're going to be learning today is about horizontal asymptotes, and we're going to figure out how to determine what the horizontal asymptote is. We're going to look at graphically and algebraically. So first, graphically, before we're looking at vertical asymptotes, so that'd be lines up and down that it never touches, but now we're looking at horizontal, so this is going horizontally this way, a line that it's approaching but never touching. So for example, this one has a horizontal asymptote at y equals 2. This is going to be a y value because it's going through a tick on the y-axis. Algebraically, there are 3 cases, and I actually think it's easier to figure out the horizontal asymptote algebraically versus graphically. So the first case is that the degree of the denominator is greater than the degree of the numerator. So first we need to look at what is a degree. A degree is the highest exponent in a polynomial. So here on the numerator, the highest degree of the exponent is x squared. So 2 is the degree of the numerator, and this 3 down here is the degree of the denominator. So notice the denominator is bigger than the numerator with the degree. So that means that it has a horizontal asymptote at y equals 0. So that's going to happen anytime the degree of the denominator is greater than the numerator. The next case is that the degree of the numerator is greater than the degree of the denominator. So here, the degree of the numerator is 3, the degree of the denominator is 2. So that means that there is no horizontal asymptote. There's actually a slant asymptote, but you don't really need to know that right now. That's a slant asymptote, not a horizontal asymptote. The third case is that the degree of the numerator and the denominator are the same. So in this case, you have to use this proportion. The horizontal asymptote is the leading coefficient of the numerator divided by the leading coefficient of the denominator. And the leading coefficient is just the number in front of the term with the highest degree. So let me show you what that means. All right, so here we can see that the degree of the numerator is 2. The degree of the denominator is 2. So that means that we're going to use this fraction. So we're going to take the number in front of x squared, which is just 1, and then the number in front of the x squared on the bottom, which is 2, and that is going to be our horizontal asymptote. So here, the horizontal asymptote is at y equals 1/2. All right, we're going to do the same thing from the bottom. So notice that the degree of the numerator and the denominator are both 1. So we're just going to take the numbers in front of this, which is our leading coefficient, and we're just going to put that as our fraction. So it's going to be -2 over 1, which is just -2. So the horizontal asymptote here is at y equals -2. All right, let's move on to some more examples, and then I think you guys will be good on this. All right, so what we're going to be doing is finding the horizontal asymptote of each. So we're going to start with example number 1. Anytime that there's just a number, that means that it has x to the 0 power there. So we're going to look at our degree of our numerator, which is 0, and the degree of the denominator, which is 2. Since the degree of the denominator is bigger than the degree of the numerator, then that means we're going to have a horizontal asymptote at y equals 0. Okay, so let's just double check on Desmos. Okay, this is our first thing here. And you can see that both of the ends are connecting. They would be connecting at the line y equals 0. So let me just type in y equals 0. Let you see. So you can see that this is the line that it's approaching but never touching. I'm not really sure what that one is. But... Okay. So this is for our first one. For the second one, the degree of the numerator is 3. The degree of the denominator is 2. So since the numerator is greater than the denominator, that's going to be case number 2, which is no horizontal asymptote. And I usually just abbreviate it as HA. Okay, so if we look here on example number 2, all right, this is the second one. And you can see that the two ends, if you connected them, they would be a slanted line. Okay, that is not a horizontal, that is a slant asymptote. So that's why they call it a slant asymptote. And you can just see that there's no horizontal line there. So let's look at example number 3. All right, these are both x to the first. So since the degree of the numerator and denominator are the same, then we're going to use the numbers in front. So in front of x is 1. So we're just going to use this fraction, 1 over -3. So the horizontal asymptote for this one is going to be at y equals 1 over -3, or you could write this as y equals -1/3. All right, and let's just check this on Desmos. So we're looking at this third one now. And it should be at y equals -1/3. All right, and let's graph this. And there you can see that both of the ends are approaching this -1/3, but never touching it. Okay, that's all that I have for you today. I hope that you guys enjoyed this video and have a great rest of your day. Bye.